Hello everybody, I'm Reza. Today I'll be talking about DIY musical instruments using Unity, Wwise, and actually I lied not only gain controllers I'll be talking about today, but microcontrollers as well and some MIDI instruments. So who am I? I'm Reza, audio lead at Creative Mobile currently, formerly audio producer at TinyBuild, and I've been freelancing as an audio producer or manager and even asset maker sometimes for 12 years already. In my spare time, I create weird musical instruments. This is my pet project, Reza and the Robotic Orchestra I'll be talking about, which is basically the YouTube channel with tutorials about how I make those instruments. And I learn something and I share this knowledge in the process. The Robotic Orchestra is a machine which responds to my input, reworks it, adds some features to it, and then outputs some sort of art, which becomes not only my work of art, but I have the machine, so it's like cyberpunk stuff. Basically, it's supposed to be a live looping set, and someday I'm hoping to get on the street and bask with it. But today it's only a plan because there is a lot to be made before I go basking. There are some crucial parts about this project. For example, the inputs I'll be talking about today. This is the most fun part. The middleware, like game engines, it's currently Unity. Audio middleware, currently I'm using Wwise. And some additional scripting I'll also talk about today. And also there are some outputs like headphones and Bluetooth speakers. Actually, I'm planning to create some surround set from the Bluetooth speakers when I go basking someday, I hope. Yeah, and I've forgotten about the most crucial part, which is marketing. All those social networks and promoting of the materials is actually very, very important. So don't be like me and do it during the pre-production as well. Let's begin with the inputs. When I first created the project, I made this huge design document with the product specifications. And for the inputs, there were some requirements like simple to operate, coolish looking, and cheap, or I should reconsider what cheap is. Spoiler, I had to reconsider. So my first input I tried something with was the generic MIDI keyboard. It was the Complete Control S88 and its sustain pedal. This time I was making some project about vehicles which had different moving parts like gears, tires, turbines, and so on. And I needed the RTPCs to control the quantity of those details, which we put onto every vehicle. And I controlled all those RTPCs with the potentiometers, and with the sustain pedal, I control the engine itself. Actually, I found the video on YouTube created by Baraknil Boya. She made an explicit explanation for that, for binding the MIDI controllers to Wwise. So check it out if you want to do that. The next thing I tried was something more complicated, like Rolly Seaboard with all those slides, glides, and channel pressure. I really wanted it to work because it's fun. But I didn't succeed because Seaboard uses some other MIDI protocol called MPE. It's more sophisticated, it has more functions, but unfortunately it isn't compatible with Wwise. And if we want to use it with Wwise, we need to wait for the software update from the developers. But it can still be used with Contact Player or whatever. The third thing I tried were the virtual MIDI inputs, mobile apps like MediGrid or TouchOSC. Metagrid works perfectly with Reaper, but it wouldn't work with Wise as well. I asked the developers whether they are going to make it compatible. They said that yeah, someday, but not now, so we're waiting as well. But TouchOSC, which you can see here at the picture, works perfectly. You can add some buttons to it. You can add potentiometer is the faders. Everything is virtual, so you can basically control Wise with your iPad or phone, and it's fun. Very functional. The next thing I tried were pre-programmed MIDI instruments. This is Playtron, made by Playtronica. You can connect any conductive objects to it using the alligator clips. I, for example, used some vegetables, fruit, and cutlery. And then it is MIDI pre-mapped. So if you make a Synth1 instance, for example, in Wise, and you bind the MIDI instrument to it, you can instantly play it. It's very cool. That's what I did with the interactive music hierarchy in some events. Here you can hear the stinger. Some loops as well. This is a Belarusian song, Kupalinka. I'm trying to play here. And the melody is played with the sampler which I designed in Wise. The next thing I tried were microcontrollers. For example, Arduino. I just got to their website and I saw this beginner set or something like that with a book with different projects. I loved it because I could learn something from that. I was an absolute beginner when I started that. And I have made several projects with Arduino, which was a complete fun. And I'll take a look at those. Yeah. My first project was Light Theremin. It is basically a project from the book. It is called like Theremin as well, but in the book the output for the theremin is the buzzer, and in my project the output for the theremin is the PC, the MIDI bridge, and Wise, which gets data from the MIDI bridge, and that's how I can control the RTPCs in Wise with the Arduino inputs. Here I have the photo transistor, which gets the amount of light getting into it, and it controls the green RTPC, the pitch, and the second controller is the potentiometer, which controls the volume. That's how it works. It's super simple, and I actually have a tutorial about that on my YouTube channel, so you can check it out. My second project was the RGB theremin. I also have it here. I have everything here. It is something like the simple theremin, but it has 3 photo transistors. Each one has a gel on the top of it. There are gels of 3 colors, so only the color of only this certain color gets into the every other photo transistor. Then this data gets into Arduino, it gets mixed, and the output for the mixed data is this lamp, which changes its color as the data changes. So it looked fun for me, and then I found this Pixel Sound audio toy by PDX on the Audiokinetic blog. This is the project in Unity. where you can hover over different gradient colors. And there are RTPCs in Wwise like red, green, blue, and gray, which get the data from this color and play the sound based on how much of every other color is in the final mix. So I just decided to mix those two projects together, and that's what I got. It is my RGB theremin. The Wwise project and the Unity project was completely made by PDX. It is open source. So I used it. I just modified the script a little bit, and that's what I got. You see the lamp, is of different color every other second, as I'm using my phone as a flashlight. So that was my first serious project, I think. And the next project was a bit simpler. I just got a sensor kit from the Arduino store. It consisted of several sensors and some new sensors like the humidity and temperature sensor, which I also used in this project. So I got all the Arduino stuff I used before, and I made some new scripts. So here's what I got. I controlled the volume with a potentiometer, as I did before. There is some loop from the interactive music hierarchy plane. And here on the screen you can see the data from Unity, because I made the script myself. Yeah, the photo transistor controls the effect, and the humidity sensor controls the playback speed. That was awful. The next project I made was the scale theremin. It is basically the same as the live theremin, but it has this stair-like RTPC, and it also used the sampler I designed in Wwise. So this is a harmonica, which sounds like an actual harmonica. Then I decided to take a look into microphones, but there was a problem. The latency was huge. There were some tweaks to get rid of it, but it required some deeper digging into the topic, so I just decided to put it aside for the better times and try something with the game controllers like PS4 DualShock controller or Xbox controller. That was the time when the lockdown began in the Netherlands, and it was winter. I couldn't just come out of the house and go anywhere because it was cold. So I decided to stay at home and to play some fitness game to stay fit. I chose Ring Fit Adventure on Nintendo Switch. And while I was playing this game, I thought that I could make use of it. I could make some musical instrument out of the ring con. Yeah, why not make an instrument of this? And the instrument which I think resembled the ring con a bit was a real accordion, so I decided to make this ring accordion out of Nintendo Switch ring con. I thought that was witty. Yeah, so when I started the pre-production, my first question was, has anyone done that before? And the answer was no, so I decided to proceed. The second question was, are there any libraries, SDKs, APIs, or whatever? And the answer was as well, no. there was a Looking Glass library on GitHub, which featured the Joy-Cons. The Joy-Cons, like those things, and you could control objects in Unity using the accelerometer, the gyroscope, the buttons, and so on. But when you connected the Joy-Con to the Rincon, it would stop working. So that wasn't the idea of what I wanted to do. And the second way was to become a Nintendo Switch developer, which made it like serious. And I wanted this project to be non-profit, open source, and not to be downloaded from Nintendo Switch store. It just was scary. So I decided to go for another option and just to suffer. Yeah, luckily I found a video on YouTube which explained what was inside the Rincon. Spoiler, it is a flex sensor, which is situated somewhere there behind this panel in the ring itself. What does it do? It gets the data from pulling and pushing on the Rincon, and this flexion data gets into the Joy-Con because the ring doesn't have any power supplies in it, and the only battery it has is in the Joy-Con, so the data goes into Joy-Con, from the Joy-Con it goes into Nintendo Switch, and that's exactly how you can play Ring Fit Adventure. I also found some awesome guys. First one was Super Louis 64, who made a mode for Dark Souls. You can literally play Dark Souls with the Rincon and with the leg strap, so you can just run into this scary world and fight with the monsters using the Rincon. It was crazy. There are also some mods for Zelda and some other games. But the problem is that if you want to play it, you need to buy some additional hardware. And that wasn't an option for me. The second guy was Mike Chowie, who made the controller himself. He designed and 3D printed something like the Joy-Con, but it also connected to the Rincon, but it had its own flex sensor and some other buttons. So the idea was that you can ride an exercise bike made with a Nintendo label and use the Rincon as a steering wheel. And the whole thing was called Label Fit Adventure Kart because you can play Mario Kart. But it was a customized object as well, so this wasn't an option for me because I wanted this project to be open source and instantly, as you download it, you can play it. That was my idea, so I didn't go for any of those options. But I decided to just learn what's inside the real accordion. It is super interesting, but I wouldn't speak about that today because it's not so digital. What I found important for my project was the real accordion had 3 different keyboards. The first one was for the one-shot notes. The second one was for bass notes and some chords like major, minor, diminished, and something else. And the third keyboard was for switching the timbre. So the idea of first prototype I had in mind was featuring the bellows, pulling and pushing. Also, when you place the Rincon higher or lower, it changed the pitch, and if you rotated it over some axis, it changed the scale. Yeah, somewhere at this moment I thought, come on, there should be something to get directly to the Rincon data because it's here, like the flex sensor is here, but I cannot get this data at all. Luckily, I found the Rincon driver by WinRun RMG, which emulated the Rincon as if it was the Xbox controller. The first prototype I made with that was a bit clumsy, but then Runner MG made a special edition of this driver, which took the exact data from the flex sensor, and I could bind it directly to the RTPC. This saved my project, literally. So thank you very much, Runner MG. This was my first prototype. It became a bit viral on Twitter, though it didn't work every time I tried to pull and push on the Rincon. You can see there. Nope. Yeah. The second prototype was featuring the Peach. I decided to bind it to the rotation, and it was an awful, awful idea because I created the monster. I created some weird theremin. I didn't like it at all. Yeah, that was a moment when I decided to take a look at something else and try to resynthesize the timbre, because I thought that maybe the pieces recorded from the VST library were a bit against the law. So yeah, I decided to remake it in Wwise. I used Isotope RX. So I adjusted the pitch of the harmonic, of every harmonic. Then I adjusted the level. Then I added some transients. Yeah, I added some transients. Those are share sets. I made several of those to make it sound more natural. I also added some LFOs. This is the first one. There were 2 more. Just do the slight vibrato. Actually, I googled every other frequency, so I could just write in the exact amount. I made several instances of Synth 1. I made several share sets for the LFOs and the transients, and then I also added some harmonizer effects on top of every instance of Synth 1, just to reduce the amount of the instances. And I got the timbre. It sounds good in the end. Yeah. Then I tried to do the rotation thing. I decided to bind, to finally bind the scale to it. Yeah, but there was a problem that when I positioned it like that, I thought that looked like a real accordion. It wouldn't work properly, so I had to do it like that. The next step was making buttons. I prototyped it on the real Xbox controller. I designed some sounds for the buttons because I just realized that the experience consists mostly of pushing those buttons on the real accordions, like physical buttons. So I added some sound on top of those. I also added a transposition feature to it. When you moved one of the joysticks, it moved the whole scale like a semitone higher and a semitone lower. But when it worked perfectly on the Xbox controller, but when I tried to test it on the real Joy-Con, this joystick wouldn't work properly, so I got rid of this feature, though I liked it a lot. Then I made some visualization. This is a 3D model made by a composer, Mark Jiguera. Thank you, Mark, a lot. And I also made some weird ornaments, like Belarusian ones, made of the Nintendo Switch logo. Yeah, so I made this open source project. I placed it on GitHub, and I made a live demo about that.
You can
how it
switch
worked.
the keys by pushing the buttons here. For example, you can try it in C and try it in A. You can switch from major to minor by tilting the ring-on. And of course, you can push and pull on the ring-on, like on a real accordion.
Yeah, so that was my project. I was super proud of it. And the thing with the triads actually worked like that. There is an RTPC bound to every middle note of the triad, and when you rotate the ring-on, this RTPC makes the tone like higher lower by a semitone, so it simulates major and minor chords, but it's simply an RTPC for one note. I also made a DualShock double bass finally, because I thought that my orchestra needed some bass, and this was a plan. I have a very squeaky chair. So those are just buttons. It isn't on GitHub yet, but it's super simple to make by yourself. Yeah. So thank you for watching my talk. You can just read my weird jokes on Twitter and take a look at my YouTube channel. I also wanted to thank every person who helped me with the production of the ring accordion. I also wanted to thank Martin Stig Andersen and the Danish Film School, and Rob Bridget, Lydia Andrew, and Ben Minto, who were, all of those people were part of the Leading with Sound seminar, which inspired me that much. So I just came to a conclusion I should make this project. So yeah, thank you guys, and thank you, Damon Kaspar, for inviting me to GDC. I hope you like my talk and my project. So if you have any ideas of what I can do next, please contact me. I'm open for that. Thank you.